Okay, so you should have had a chance to take a look at your guided practice. Let's go ahead and take a look at those right now. So the very first guided practice question we had, we want to figure out the mass of silver present if it requires 225 joules of heat to increase the temperature from 13.5 to 45, and the specific heat of silver is 0.233.
Okay, so that's a pretty straightforward.
Yeah.
Q equals MC delta T. We're looking for the mass.
We know Q.
Because it tells us it's 225.
All right.
I don't know M.
We do know C. It gave us that. So
0.233.
And delta T is the change in temperature, so we got to subtract 45 and 13.5. So our change in temperature is
31.5.
31.5.
So I'm going to multiply that by my specific heat.
There you go.
Yeah. So those equals 7.34.
7.34.
Don't forget your M.
Times the M.
So we need to get rid of the 7.34. So 225 divided by 7.34 gives us 30.65.
30.65 grams.
And that's
the mass of the silver.
Yay!
Oh, that's pretty nice. Whoa, this one looked like
Oh no, there's
it
too
was
many numbers.
pretty crazy, but it's actually not. All we're doing is we're just doing Q equals MC delta T.
All right.
We just do it 3 times in the same problem.
Oh.
Okay, so the very first one, well, I'll tell you what, let's go back and label the different parts.
Okay.
Okay, so like this little part right here is A, this first little slanty part. Then the flat part right here is B.
Okay.
Okay, going through the alphabet,
C.
D, and E.
Yay, know my alphabet.
Yay! So, I have nothing to say for that. Okay.
Okay.
So then what we want to do is we want to figure out how much heat was involved at A. So
Okay.
we're going to do Q equals MC delta T. Q is what we're going to be looking for.
Right. For A. Okay.
Okay, so we got Q. M, the mass is the mass is going to
stay
same.
right.
Yeah, so it's always going to be 20. That's going to make it easy.
We always have the same sample.
Yep. Now, this particular area, what are we?
Okay, so
what state of matter?
we're frozen, so it's a solid, right?
Right.
Solid frozen. And so it would stop being solid at 0 degrees. It would melt when you hit
Right.
0 degrees.
So we are starting at
Negative 40.
negative 40 to
Okay.
0.
So that's 40.
Right. And then to figure out, because I've got 3 C values, you said it's solid.
Right.
So we're using the 2.06
Right.
as the C. So 20 times 2.06 times the 40 degrees.
Right. Because it only took us to negative 40 to 0 is 40. So I can multiply that 20
Yeah.
times 2.06 times 40. And so that is 1,648.
Okay. B, that's when it's changing from
Right.
solid to liquid.
We
but
have our phase change there.
We
Okay.
They gave us that number. Same thing
Yay,
with
we're
D.
not going to make you calculate that.
We are going to calculate C, but we're going to do the
Same thing.
The same
Q
thing.
equals
So
MC delta T. So still 20 grams. Except now we're in liquid form because we melted.
yep. So now we're going to want to use
Okay, so liquid,
liquid
water.
4.18, and the temperature change. We're going from 0.
Right.
to
All the way up to, well,
100.
our next stage would be evaporation,
Right.
which happens at 100. So
Yeah. So 100 minus 0 is
100.
100. Okay. Now we want to multiply all those together.
So 100 times 4.18 times 20 is 8360.
Okay, and then the D is our changing from the liquid to the gas.
That looks like a 9.
Does that look like a 9?
That looks like a 9.
It does look like a 9.
8. That doesn't really look any better. Hold on a second. Meow. Yep. 8.
That's
There we
better. That's a much better 8. The other one looked like it was it looked like a 9 that was pregnant with triplets.
Something like that.
All right, then E, we're going to go ahead and do the last one, still doing Q equals MC delta T. Our mass is still 20. Now we are at a vapor at that point, so we're going 2.02.
Vapor is gas, guys, for those of you who don't know.
And then our temperature change, our starting point is 100.
So 100 to 130, so
going up to 130, so
30.
it's
The
a
difference
30
of 30.
degree. Yep.
So times 20 times 2.02, and we got 1212. Okay.
Now, if you notice, it says, I erased over, or I wrote over, but if you notice, it says total.
Mm-hmm.
So we want to know how much energy is involved from -40
All
to
the way up.
130. So we want to
We gotta add all of those.
add all
up.
of those together.
Okay, so that one plus.
All right, and we got 63,100 joules of heat required to change 20 grams of steam at 130 degrees Celsius to -40 degrees Celsius.
All right, so we basically were changing steam and we were freezing it and making it go down to a solid, but the energy change is the same
Yeah.
either way. But because we were going from a gas steam to a solid, we were going down. Okay, so the temperature is getting colder, therefore it is absorbing energy.
So it is endothermic. Cool.
Yep.
Alrighty.
So it says endothermic right
Oh
there.
yeah, I didn't see that last part. Alrighty.
Okay.
That's basically it. Sally forth, keep calm, carry on, buy war bonds, whatever other World War II cliche taglines you can come up with.
Ah.
And I'm